We're going to do this one, and then we will do the application involving, I think, a gravel pit, I want to say, coming up next. And if we have time, we're going to swing back around and do the first one, which is really similar to this one. We'll at least shoot to do part of it. So yesterday we did A, and we found answers for G of 0 and G prime of 0. What did we get for G of 0? You said 4? 4.5. And what did we get for G prime of 0? 1. Okay. So then let's go ahead and go in order here. Question B says, find all the values of x on the open interval, -5 to 4, at which G attains a relative maximum, the word relative being quite important. And then it uses this phrase, this sentence here, justify your answer. It's a very strong sentence. They're really wanting you to be very rigorous about the way you explain yourself. So it's like one step beyond the show the steps leading to your answer or explain how you got your answer. This needs to be like, really a rigorous explanation of what the reasoning is for your saying that you've got a relative maximum. So please do take a look at the graph, take a look at the question there. Try B. Think about how this works. We're looking for x values where G has a relative max. And so that graph is a graph of F. So as far as looking at that might be useful. But we're looking for relative maximums of G. So if I'm looking for relative maximums of G, my candidates would be what? Let's not go specific. Like conceptually, my candidates would be critical points of G, right? And this is where just saying like critical numbers or critical points probably not enough, because if you start thinking about critical points of F, is that the same as the critical points of G, and how does that all work? So critical points of G, so that would be where G prime is equal to 0 or doesn't exist. And so I think in A we found this. What is G prime equal to? It's equal to f of x. And so maybe we write something like this down. G prime of x equals f of x equals 0. Making this connection between G prime and f, kind of like we did the same sort of thing in A. Really important connection to be made there. Okay, so then we turn to the graph and we're like, well, gosh, I guess the zeros of f would be the critical numbers of G, wouldn't they? All right, so my candidates, and it didn't say that we had to work with all the candidates necessarily. Here's my zeros. Here's one right here. There's another one right there, and there's a third one right there. So there are 3 candidates. Of those 3 candidates, how many of those would produce a relative maximum for G? Only one of them when x is equal to 3. Okay, that's right. So we could really start into kind of our summary and our justification here. We could say something like G has a relative maximum at x equals 3. So that's kind of declaring the answer, right? I haven't really justified anything yet. I'm just saying, hey, the relative max is when x equals 3. I'm going to say because. What do you think needs to be involved in the because? What about f of x?
F of x is the actual graph. So you'd say f of x goes from positive to negative at x equals 3.
Okay. I agree we need to look at the sign change pattern. And? What equals 0?
F of x or g.
AKA g prime, yeah. So once you have made a connection like this, you can use them interchangeably because you said, hey, when I say this, I really mean that. And if I say that, I really mean this. So you can use them interchangeably, but you do have to have both elements. You've got to say, I'll put it in this order, I guess. You could say because f of 3 equals 0 and f of x changes from positive to negative at x equals 3. So you got to have both of those elements because just because f of x or g prime goes from positive to negative doesn't really mean much of anything on the whole relative max thing. That behavior has to happen at a critical point. You have to have a continuous function for this whole first derivative test thing to work. So you got to have both elements there. You don't have to mention continuity. They usually just let you slide on that one. I'm okay with that. All right, what do you guys think? Good? Okay, well, then let's move on. C is a little bit different, although it does have some similar features. It says find the absolute minimum. So B asked for a maximum, a relative maximum. C asked for a minimum. But what's the key word as far as determining how we approach this? Absolute, right, or global. That means we have a closed interval, a domain that we're going to be looking at here. And so for this one, not only are our candidates going to be the critical points that we might find, like we found in C, but also endpoints. So you got to consider both. That's going to change how you handle your strategy here. So again, I want you guys to try C, work it out, see how it goes for everybody, and we'll look at answers together here in just a minute. Let's look at this. Looking for the absolute minimum on that interval, -5 to 4. So I think it's always a good idea to list out our candidates. I'll just list them out in a table right here. We are looking for x's, and then of course we'll have y's to go along with those. So what would be the lowest candidate? -5. That's the lowest valued candidate. Okay, then we're looking for critical numbers. So what would be the next candidate? -4. Agreed. So -4. So here is where you can probably make a wise decision. X equals 1 is a critical point, isn't it? But what is happening there that would tell you that it's not going to be the absolute minimum? There's no sign change, right? So it's probably a point of inflection, and so that's not going to be a max or min, like an internal point of inflection like that. So I think we maybe could skip that one. The next one would be the 3. But if you think about it, wasn't the 3 a relative max? So if you just wanted to put like it's a relative max over here, and if something is a relative maximum, there is no way it could possibly be the absolute minimum, right? It's just unreasonable to think that. So you could just say, yeah, I realize that's a candidate, but it was a maximum. We already found that, so I'm not going to really concern myself with that too much.
Right?
Say again?
Like we don't have to re-justify that as a maximum?
Nope. No, yeah, B would suffice for sure. And then, of course, you've got the 4 as the other endpoint. We do have to consider that. So then how is it that we actually judge these? Like we learned back in section 3.1, we need to complete this table, find the y values to go with the x values, and then we just pick the lowest number, like the lowest output. That'll tell us what the absolute min is. So all I got to do here is find, and I say all I got to do, there's a little more involved than just finding it, right? It takes a little bit of effort for sure. I need to find g of -5. The good news is I have a really nice function describing g of -5, but that really nice function involves an integral, right? An accumulation function. And not only that, when you plug this in, don't you get the integral from -3 to -5 of f of t? What's so awkward about that? See, that's the wrong way, right? The limits are accumulating from right to left instead of left to right. We're used to going left to right. All of our, conventions, bless you, are based on left to right. And so maybe we write g of -5 equals the opposite of the integral from -5 to -3 of f of t dt. Something like that. That makes sense? Flip it around, accumulate from left to right. You could go the other way if you want. I like this way. All right, so -5 to -3, what's going on there? Equals 0, right? So if you look at the areas up there, this area right here is, it's not really, if I say area, the area is never negative, but that accumulation would be -1. and then to this point right here, well, this accumulation would be positive 1. So as you accumulate from left to right, you get negative 1 plus 1, which is 0. So I'd put a 0.
So it's the opposite of 0.
Say again?
It's the opposite of 0, so it's negative 0.
The opposite of 0. Okay. I'll let you put that. I won't take that risk. Okay. So there's that. Then we could say, I'm going to erase this, and you'd want to have that. I'm just going to erase it for lack of space on my part. My little Apple Pencil doesn't get that fine. So then I also want to work with g of negative 4. So g of negative 4 would equal the integral from negative 3 to negative 4 of f of t. And we have the same issue, right? We want to flip this around. So it'd be g of negative 4 equals the opposite of the integral from negative 4 to negative 3. Here the negative is going to matter, right? Because if you go from negative 4 to negative 3, the accumulation is 1. But then the negative out front makes it negative 1. So there's negative 1. So far it looks like negative 1 is the absolute min, right? We keep going, catching our last one here. It's a little more complicated, I guess. G of 4 is equal to the integral from negative 3 to 4 of f of t dt. So this is the most complicated one, I suppose. So let's see here. G of 4 then equals, if I start at negative 3 and start accumulating, that's that 4.5, isn't it? Right? It's the rectangle and the triangle. So positive 4.5. And then you get this semicircle, right? Yeah? So how'd you guys handle the semicircle?
I will guess.
You just guessed? What did you say, Jasmine? Does it make sense to you guys to look at this like a rectangle and then just subtract out the semicircle to get these little, I'll put them in purple here. Isn't that what we're after right there? Those little shaded in purples? So if you subtract the semicircle from the rectangle, that's what you get. So that would be plus the quantity of 2 minus, and that semicircle would be pi over 2. So pi over 2 area for that. And then you've got, well, really, if you think about it, don't you have two little triangles that would just cancel each other out? So like the triangle that I'm highlighting in red, that would have an area of 1/2. This would have an area of 1/2, but one's above and one's below. So wouldn't they just accumulate each other out to be a 0? So let's see here. I end up with 6.5 minus pi over 2. I'm really not that concerned with exactly what that is because I'm looking for the minimum. Is 6.5 minus pi over 2 bigger or smaller than negative 1? Clearly bigger, right? Pi over 2 is like 1.5 roughly. So that's actually closer to about 5. You can see how that positive accumulation supports that. So my conclusion then would be, therefore, the max is negative 1. Looking for the y value there? Who wants to know what the max? How about the min? Let's go with that. Isn't that funny? You got all these numbers that point in one direction, then you write the exact wrong thing. It happens, doesn't it? All right, go ahead, Johnny.
For four, x equals 4, is there a way, like, you just say it's going to be way positive because, without doing all the math, because, I mean, you can see if the triangles cancel out and then you can see it's above x-axis.
I feel like that's more work, right? Because you'd have to use a lot of words, and I don't know for sure if that would work or not. I mean, if you really explained it well, it probably would work. Yeah, you'd have to say, well, okay, so here'd be an example. You say, starting at negative 3, you get a triangle and a rectangle that are pretty big, and then you get a little more positive accumulation with the little semicircle routine, and then a little more positive accumulation with the triangle, but then you get some negative accumulation, but that negative accumulation is smaller than all the positive. You see what I'm saying? Like you end up with this paragraph versus you write on an integral, you add up some areas, and you get a number, and as you leave that alone, you think to yourself, unless I made an arithmetic mistake, I nailed it. Versus I wrote this paragraph, and I'm like, I sure hope I said everything I need to say. To me, using numbers is always better if you can. There have been occasions in the past where comparing the relative size of areas was the thing because you didn't have any other information. But if you got more information, like you know how to find areas and such, I would use numbers. That would be what I'd recommend. Yeah. And your question, or is that your question? Same one? Okay, yeah, go ahead.
But, so going off that, do we need to be specific in that? Like, we can't just say G of 4 is greater than 0? Like, we would need to prove that it's...
You'd need to have some work to support it. Like, I would go back to the, do we write a paragraph or not? If you just say, hey, G of 4 is bigger than 0, I would like to have some kind of understanding as to how you got that. And to me, the easiest way is to just do run some numbers based on the information you're given. Jade?
So can you mix it, because you know the area is 4.5, so could you say that it's like G of 4 equals 4.5 plus 0, since you know that, plus some positive area, therefore it's positive and greater than 0?
But then there's also the minus the little area at the end, right? You can't totally ignore that.
Isn't the area at the end just 0?
Well, no, so
Between 2 and 4.
from 3 and 4. Yeah, between 2 and 4 is 0, but you just said it G of whatever it was is 4 G of 3 is, or G of 0 is 4.5. You could absolutely bring that in. You could say, hey, G of 0 is 4.5 plus a little bit, plus a little bit, plus a little bit, but then you can't ignore that now there's minus a little bit too. Does that make sense? So you'd have to explain it. You can't just, does that make sense?
So you can't just say 4.5 plus 0 since it cancels out plus a positive area?
So
Mix the two?
explain, yeah, you maybe could, but make sure you explain yourself really well. And my point is that in the explaining of yourself really well, you might say to yourself, gee, it would have been a lot easier if I would have just done some numbers. Because once you're 3 or 4 sentences into it, you're all good at math, and it might be I wrote 4 sentences. I could have just been 2 minus pi over 2. Does it make sense? So I'm not against that. What I would say is make sure you really explain yourself. Don't just be well, duh, we can see it from the picture. Well, maybe you can, but somebody who is not quite as good as you probably couldn't. So explain yourself well, and I think numbers, if you think about it, numbers say a lot in a short amount of time, or a short amount of space at least. So I would consider doing that. I really would. So you could do what you're suggesting. You really would. Okay, if you haven't already looked at D, please do. This is another excellent opportunity. This brings back a little bit of chapter 3 stuff. Excellent opportunity to review a little bit. It says find all the values of x on the open interval -5 to 4 where G has a point of inflection. And I'm going to erase some of my writings on the graph there so I can point out some other stuff. For points of inflection. So let me ask you this first. How many points of inflection do you think G has?
3.
There are 3 of them. I think I agree with you on that. Informally, we're looking for relative extrema of G prime, right? And since G prime is equal to F, I can come up here and look at my graph and say, all right, well, wherever G prime equals F has a relative extrema, say right there, or there, or there. So -3, 1, and 2, that's going to be where G has a point of inflection. And it does say, you know what? It doesn't say anything about justifying your answer, does it? It really doesn't. So, you could just really write x is equal to -3, 1, and 2. Just in the spirit of fully explaining ourselves, bless you, let's practice this. 2 of these inflection points have the exact same characteristic. Which 2 have the same justification? -3 and 2 have the same pattern, don't they? So you could say, because at x equals -3 and x equals 2, G prime goes from what to what? That's right. Let's avoid the vice versa thing. Often they will accept that as acceptable reasoning. Sometimes they don't. Sometimes they get real picky, and they want to see that you're not kind of recipeing it, and they want to see that you're specifically applying your reasoning to this question. So then you'd say something like, also, you can't really see that, at x equals 1, G prime goes the other way, goes from decreasing to increasing. Okay. Any questions there? Sorry, let me get this on screen. That's a little better, but now it's right on the board edge. All right, we solid? Just trying to apply all these concepts we've been learning. Now let's apply it to a more contextual example. So let's move forward to the gravel question. Yes. Anytime a question has a name like that, you know it was tough.
The potato question.
The potato question, yes. The baby bird question. The landfill question. Last year, you know what it was? It was the escalator question. People are like, why would someone wait in line that long for an escalator? And they get so mad. Anyways, so take a minute, please. Read this over. This is very contextual.
I'm also leading
And I know, listen, I know that even though you guys are really good at math, that sometimes when you look at a word problem, there you are, but when you look at a word problem, sometimes don't you get like that lump in your throat a little bit and you're like, oh, word problem. I know. So guys, here's what I recommend you do. First thing, just read it over just as a story. Just try to read it real quick and say, hey, what's going on here? And don't get too concerned about numbers and stuff. It's a really short story. It's like just a couple sentences. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T. So the way that I interpret that is, there's some gravel coming into the plant. That's it. That's all I care about right now. At the beginning of the workday, the plant has a whole bunch of gravel in it that's been unprocessed. And then during the hours of operation, the plant processes the gravel at a constant rate of 100 tons per hour. When they process the gravel, they're probably just crushing it up into smaller little tiny rocks. That's really all it is. So once you've read it over for meaning, just read it like a story. Then you want to start digging a little bit deeper and start to try to answer the questions. You got some key rates. The rate at which the unprocessed gravel arrives is modeled by G of T. I think I'd try to bring that out. The plant processes gravel at a constant rate of 100 tons per hour. I think that's another important rate. This is calculator active. So when you get to A and it says find G prime of 5, I would certainly use the calculator. I'd certainly make sure that I was in radian mode. So please do calculate G prime of 5. And then this might be something really worth parking on for a couple of minutes, and that is using correct units, interpret your answer in the context of the problem. Hey, you're in math class. Do this. Not whatever that is. Quick, what did you guys get for G prime of 5? Negative 4? 24.588? Okay. That's what like 3 or 4 folks are saying. That would be your math 8 done with G. Is that good? Okay. I'll put one down here, and I think there's probably more than just this one that could work. So that G prime is negative, right? And so in the context of the situation, the fact that G prime is negative means something, right? So what I'm going to say is G prime of 5 equals negative 24.588. This means that the rate that gravel arrives is decreasing the rate that gravel arrives is decreasing at a rate of, and this is where people can get into a little bit of trouble here. What should be the next thing that I write? Yeah, you got to write 24 positive 24.588. Units would be tons per hour, or hours squared. Yeah, I could go with that. So tons per hour squared. So here's where it gets into trouble. So G is obviously already a rate, right? But we don't need to get too hung up on that other than with the units, I suppose. The fact that G prime is negative means that whatever G is decreasing, right? And so you could say perhaps, you could have said something like G of t is decreasing. That's a little bit less contextual, but I think it would still be okay if you said G of t is decreasing at a rate of. And then the big issue is usually the double negative thing. If you said that G of t is decreasing at a rate of, and then you say negative, you're saying that something is decreasing at a negative rate. You're actually telling me that it's increasing, which is not true. So you're going to be really careful that you tell me that it's decreasing, that this G of t is decreasing at a rate of 24.588. The least contextual would be to say something like G of t is changing at a rate of negative 24.588. And most years that's acceptable. I typically will take that as the least contextual. That'd be like the lowest bar. The highest bar would be maybe something more like that. So consider. Do you guys have any questions on A? I saw you all trying to write out your explanations, and you might have a pretty good one, but it doesn't look exactly like that. Be happy to listen, and we can talk about it if you want. All right, fair enough. So B says, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Find the total amount of unprocessed gravel that arrives during the hours of operation. So again, calculator's active. I think that will come in handy on B. Please consider, see if you can answer B. So B says, find the total amount of unprocessed gravel. To me, these two words tell me everything I need to do. Find the total amount. I know that I have some rates in action here, but it's not that easy. Don't we have two rates? We have a rate at which the gravel arrives, and we have the rate at which the gravel leaves. Do we need to use both of them to answer this question? No, we do not. Which one do we need to use? The first one, the G of t. So if I want to find out how much arrived, I'm going to write the integral from, is it 0 to 8? Is that yeah, integral from 0 to 8 of G of t dt. Before we use the calculator and figure out what that is, I want to ask you one other question. Do we have to consider how much gravel was there at the start of the day? Because there was 500 tons, right? So do I need to add 500 to this? No. Why not? Yeah, we're asking for the amount of change, right? And if I were to put the 500 on there, the 500 is not the amount that changed. That's how much that was there before the day started. So we don't want to consider anything other than just the integral, the definite integral of G of t. So when you guys ran this through your calculator, what'd you get?
825.554.
Awesome. At least Emma over here agrees with you. So that's good. Okay, so the rest of you guys agree?
Yep.
So that's how much arrived. That's not how much is there. That's not how much was there to begin with. That's not how much it finishes with. That's just how much showed up during the day. All right, C is the amount of unprocessed gravel increasing or decreasing at t equals 5 hours. This is a nice review question as well. So if you would, see if you can answer C. Take just a couple minutes to do this. In C, I want to ask you guys a couple questions, see if you understand the concept of this. In C, do I need to consider how much gravel was there to start with? I don't. Do I need to consider the rate of gravel coming in? Do I need to consider the rate of gravel going out? Yes. I do. So the rate of gravel coming in, of course, is G of t. So I would consider G of 5 because we're wondering what's going on at 5. And that's the rate that's coming in. And so I'm going to leave that as a positive value. But I've got a rate that's leaving, and that is 100 tons per hour. And since that rate is causing the amount to decrease, I'm going to subtract it. And it's a constant rate, so I don't have to really worry about how the 5 interacts with that. I just know that that rate is always 100. So if I could figure out, using my calculator, what G of 5 minus 100 is, this would lead me to hopefully some good reasoning and a correct answer. Does anybody figure out what G of 5 minus 100 is? Negative 1.85? 3 decimals just to be consistent. 59, okay. All right, that's a neat number. We agree with that number? Yeah? What's the most important thing about that number for our question? It's negative. So I'm just going to throw this on the end. Is negative, is less than 0. Therefore, the amount of gravel is doing what? Decreasing. Correct. At t equals 5. Okay, last question. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. So this one, we've got about 6 minutes left right now. So let's work this one together. Maybe you've already started it. If not, let's just work through it together. The word maximum is right there, so that's a clear indicator of what we're trying to do here. And then this is really subtle. It says during the hours of operation on the workday. And what are those hours of operation?
0 to 8.
And it's closed on 0 and 8, right? So that is sort of a tricky way, this is an old AP question, tricky way of telling you that you're looking for what type of maximum? Absolute, right? Because you've got this closed interval from 0 to 8. So when I set this up, I am going to try to create a table. And within my table, I'm going to have T's, and then I'm going to have amount of gravel, so T and amount. And I know for sure that my lowest candidate is 0, and I know for sure that my highest candidate is 8, and there might be some critical points in between, right? That make sense? I got to figure out what those critical points might be still, but I know my table is going to look something like that. So how would I figure out critical points? Yeah, I got to set the net rate equal to 0. So G of t minus 100 equals 0. How do you solve an equation like that? Please put it in your calculator. Yes. So we're finding critical points to go along with those endpoints to consider for our absolute maximum amount of gravel. How many critical points you guys getting?
Wait, is the second one just, never mind, it's just one.
Is there just one within the interval?
Yeah.
4.923. You guys agree with Colin and his 4.923 number?
Yes.
Okay. All right, so part of this, at least one little part is pretty easy. When t equals 0, how much gravel's there?
500.
500. So that's going to take absolutely no effort other than just writing it down. But the other two will take a little bit of effort. What tool are we going to have to use to figure out how much gravel is there for the other 2 points? Math 9, integral. Yeah, so it's going to be a definite integral. Here would be your first setup. I would say 500 plus the integral from 0 to that 4.923 of g of t minus 100 dt. This should give me the amount of gravel that's there when t equals 4.923. What I'm doing is I'm considering how much was there to start with, the 500, and then I'm adding the change to it, right? So this is a real classic situation where you've got original amount plus change gives you the final amount. Hope that makes sense. So you run this through the calculator, and what do you come up with? 0.36. 376. Okay. You guys agree with that number?
What was the number?
635.376 for your critical point amount.
Can you calculate a 0 on like the graph thingy? Can you store that number?
What did you get?
That's a great question. I don't know. I don't know.
Wait,
So are we good with the 635? I know Brandon's kind of like, I don't like this number. I got something else.
I don't know what I did.
We'll look at it here in a second. I want to bring out one other point before we finish. That sounds reasonable, and it sounds like the vast majority of us have 635. Nick, do you have 635 too?
Oh, I know what I did.
You know what you did?
I already had minus 100 in my Y1, so I doubled that up.
Got it. Okay. And then 8.
There we go.
For 8, it would be 500 plus the integral from 0 to 8 of g of t minus 100 dt. So what did you come up with for that one? 525? Oh, we already had that, didn't we? Did we already have that?
Oh, yeah.
No, 825.
Oh, never mind. That's how much arrived. So, sorry, it's just the 0.551 just sort of rang a bell for me. Hey, one note that I want to let you guys know. So, of course, We're looking for maximum amount. So what is the maximum amount? 635, yep. Maximum amount is 635.376 tons. Can I point something out that's a common error? And I blame this on your like Algebra 1 teacher, maybe your Algebra 2 teacher. It seems to me, and this is very common, that whenever you have a rate that is constant, like 100, we just feel compelled to multiply it by a t, or maybe an x. Like you see a constant rate like 100, and you're just like, I better multiply that thing by t, because distance equals rate times time. I think that's where it comes from, or amount equals rate times time. So please be very careful with those constant rates. You very likely don't need to multiply it times a t. Just be careful with that. Okay, I think we're good. I hope you guys have a great rest of your day. Good luck, seniors. Football game, get after it. See you tomorrow.